Right, so welcome to Pure 1, Chapter 11.3, where this time we talk about the magnitude and the direction. So note, vectors only tell direction on the surface. Okay, so 5 minus 6 and 12, 10 minus 12 have the same distance. I think I meant same direction. Okay, sorry, my bad. Typo. Same direction because 10 minus 12 could be written as 2 times 5 minus 6, so the same vector. So 5 minus 6, they both same 5 minus 6, so they're same direction. Now, distance of a vector can be found as the magnitude of the vector, denoted as this one. We have two straight lines like a bars. We can call this the modulus of something, or we should call it modulus of something. So if a equals xy, there's actually a different way of using magnitude, but you learn in pure 2 normal maths. Anyway, so if a equals xy as a vector, okay, then the magnitude of a equals, or the modulus of a to the magnitude of, or the modulus of, so different way of saying it, equals to x squared plus y squared. You might be thinking, why is that the case? Well, actually, it's quite simple to explain. Because if you try to use here, so e.g. in here, let's call this a, okay? So let's call this a. So the vector a has x plus y. Let's say x and y are both positive. Doesn't matter, to be honest. X to the right and y upwards. Okay. Then the distance, okay, of the black line, the distance using Pythagoras, so the distance will equal to the distance squared equal x squared plus y squared. So distance equals square root of x squared plus y squared. Simple as that. It's just because of Pythagoras. Okay. Right. Anything I have to mention? Nope. Let's jump into example. Given that a equals 7i plus 24j and b equals minus 5i plus 12j, find the magnitude of a and b. Easy peasy. Magnitude of a equals square root of 7 squared plus 24 squared. You can use a calculator if you know your Pythagorean triplets, 7, 24, 25. What are the Pythagorean triplets, if you're wondering what I'm asking? So one famous one you've learned is 3, 4, 5. These are called 3 squared plus 4 squared, 5 squared. So these numbers, these integers are called the Pythagorean triplets, where they form a right angle triangle. Another famous one is 5, 12, 13. So 3, 4, 5 is one you've learned. 3, 5, 12, 13. One more, 6, 8, 10. These are famous ones. And one more, which is less known, is 27, 24, 25. There are actually a lot more, obviously, a lot more, but they're not easy to find. So these are the ones sort of I remember myself. Part B. So, no, part A, the magnitude of B, which is the magnitude. So square root of minus 5 squared plus minus 12 squared. So if you notice the minus is in that bracket, when you square it, it doesn't matter. So therefore, when we do the magnitude, you can almost ignore the negative because you know negative squared will cancel out. So 5, 12, what did I say? 13. Okay, so that's the distance. The distance can never be negative. Okay, part B. Find a unit vector of A. So what is a unit vector? Well, now, okay, so let me explain in here. So we know A, okay, is 7i plus 24. So 7i plus 24j means, let me draw it in here, like this, right? 7i, let me make it a bit shorter in here. Okay, so A, that's A. So that's A. 7i plus 24. 7i, oh, it should be the other way around. Anyway, it doesn't matter. Okay, so unit vector, so currently, the magnitude, the length of A is 25. Okay, so A is 25, means the length or distance of vector A is 25. So unit vector of A is the vector such that the length of A becomes 1. That's what unit means. Unit means 1. So think of it like enlargement. If currently the length is 25, if I want to shrink it to a distance of 1, then the scale factor will be 1 over 25 because you divide it by 25. So therefore the unit vector, so we call it A hat. So this is just a unit vector. Just a way of writing unit vector. Unit vector of A. Okay. equals to 1 over 25 of A itself. So 7i plus 24j. So that's what unit vector means. Unit vector means what's the scale factor? Scale factor in here is 1 over 25 because A was 25. The length is 25. Imagine centimeter. If I want to shrink it to 1 centimeter, I divide the whole thing by 25, divide the vector A by 25, and that's the unit vector of A. Okay, or you can expand the bracket, or you can write 7 over 25i plus 24 over 25j, but it doesn't matter. Okay, so all in all, the unit vector, so unit vector, you can write this formula down if you forgot. Okay, if you don't understand what's going on here, hopefully you do. But if you do want a formula to remember, I know how students think, then you can use this. So 1 over the magnitude times the vector. Okay, so it's 1 over magnitude times the vector. So 1 over magnitude over 25 times the vector itself. Okay, that's the unit vector. Right, part C, find the angle between A and the positive x-axis. So part C, what I'll do is can I just copy this diagram? I can. The 4 is missing, so I'll just put the 4 in there. So I want to find the angle between A and the positive x-axis. So I'm looking for this angle theta in here. So to find theta, so we can use 10. 10 theta equals 24 over 7. So theta equals inverse 10 of 24 over 7. And here you don't have to use any cast diagram because you can see this theta angle is acute. So that's 73.7 degree. I use 3SF. Okay. What's part D? Part D. Find the angle between B and the positive y-axis. So B was minus 5i minus 12j. So let me draw a diagram out. So minus 5i minus 12j, let's say that. So that's... Now, when I draw a triangle, I don't write the negative because negative tells you direction. In terms of its length, it's just 5 and 12. So I want to work out the angle between the B, so that's B, sorry, that's B, and the positive y-axis. So positive y-axis is all the way here. That's positive y-axis. So I want to work out this, let's say alpha, or this whole angle. So if I want to work out the whole angle, what I know is this a right angle, right? So if I can work out this little angle, I know it's a bit confusing in here. So there are too many lengths in here. Let me use different color. Okay, so I know that's a right angle. Okay, if I can work out this alpha angle, then I know the whole orange angle where B against the positive y-axis will become 90 degree plus alpha. So let's work out alpha. So 10 alpha equals to 12 over 5. So alpha equals inverse 10 of 12 over 5. Put in a calculator, I believe you should get 67.4 degree. Therefore, the whole angle, so the angle equals 90 degree plus 67.4 degree, which is 157.4 degree because that's the positive y-axis. Right? Last but not least, E. Given vector C has a magnitude 100 and makes an angle 30 degree with I. So what's I? So I is the positive x-axis. It's just the same as positive x-axis because I represent horizontal 1, 0. So let's draw it out. So C makes an angle of 30 degree. So E. So what do we know? That means 30 degree. Okay. And this is C. And what we know is C has a magnitude of 100. So how can we work it out? Well, if you think about this length being 100, okay, so think of it this way. 100 centimeter, 100, 30 degree, X and Y. So I can work out using trigonometry. I can use cos 30 degree equal X over 100. So X equals 100 cos 30 degree. Put it in a calculator. I believe you should get 50. Do the same for Y. Sine 30 degree equals to Y over 100. Actually, am I right? 100 cos 30 is not 50, is it? 100 cos 30. Oh, it's not 50. My bad. 100 cos 30 is 50 root 3. Because I remember sine 30 is half. That's why I'm wondering something's wrong here. So Y equals 100 sine 30 degree. And this is 50. Therefore, C equals to 50 root 3I plus 50J because we're going to the right and going up. Okay, so that's how we can work backwards. If you're happy with this, pause video, have a go at question 11, practice question 1. Pause the video. When you're ready for the answer, you can press play. So here are the final answers. Quite simple, a plus b and 2a minus c. For question C, however, to find the unit vectors, you can remember the formula is 1 over the magnitude. So it's 1 over the magnitude of a. So you need to first find the magnitude of a by doing the Pythagoras on the coefficients of I and j, root 13. So there's 1 over root 13 of the vector a. So of the vector a. So vector is 2i plus 3j. You can leave it as it is, or if you want to rationalize the denominator, make it look a bit neater. Yeah, do a bit extra. That's good for you. So root 13 over 13 times 2i plus 3j. Or if you really want to go from extra miles, you can also expand the bracket into 2 root 13 over 13i plus 3 root 13 over 13j, but that's not required. So vector, unit vector of b, same thing. Okay. So practice question 2. Okay, this time you're given the magnitude. Okay, write the following in the ij vector form. If you struggle with this, have a look into our part E again. Okay, so very similar. So pause the video, have a go at practice question 2. When you're ready for the answer, you can press play. So these are the final answers. If you got it right, well done. Good for you. Well, move on to the last exam practice. But if you don't, I'm going to go through it with you, okay, one by one. So question A. So first of all, you can draw the triangle for question A. So I'm going to use green. So question A, okay, so what we can do is we know that's a right angle and that's a 30-degree. So that's X and that's Y. Now, the reason that X and Y has to put in that direction is because, 15 is going to top right corner. So X must be right and Y up. So to make that direction of top right. So X equals to, or if you use step by step, because I've done a lot of trigonometry, so hopefully you can do this one day as well. So cos 30-degree equals X over 15. So X equals to 15 cos 30-degree. So put in the calculator, you should get 7.5. Not 7.5? No, I think 13. 15, hang on, 15 cos 30 was, oh, it's 12.99. So I got 13. Or you can put 15 root 3 over 2 or just 13. And Y is 15 sine 30-degree, which is the same as 7.5. Okay, it's trigonometry. So, yeah. Okay, now B, however, is slightly trickier. Now, B, if we draw a line in here, then we can see this triangle. 45-degree. 20 is going to bottom right. Now, to make 20 bottom right, going the bottom right corner direction, you must have Y going downwards and X going to the right. Okay, so therefore, then we can make the use normal trigonometry. So X is in the sine. So sine 45-degree equals X over 20. So X equals 20. Sine 45-degree. Put in the calculator, you get 10 root 2. For Y, cos 45 equals Y over 20. So Y equals 20 cos 45, which is 10 root 2. Now, however, you might be wondering, why is it negative in here? Because X is going to right, so X is positive. But Y is going downwards. When Y is going downwards, it's negative. That's why it's negative in here. Okay? Put in here, negative Y because going downwards. Because the vector is going downwards. Okay? Right. So, exam practice. Pause video this time, given that the magnitude or the distance of 2i minus kj is 2 root 10. Find the exact value of k. Think about how you normally work out the distance and magnitude of a vector. Okay, and form an equation. Pause video, have a go at the question. When you're ready for the answer, you can press play. Here's the answer. Okay, actually, there's a typo. There should be values of k. My bad. So k equals plus or minus 6. All right, 3 marks. And that's the end of 11.3.